Okay, Charles Demler here again, Project Charles, projectcharles.org. Um, I got into a little bit of talk with other people about what I can do, what I can't do. So, of course, gravity comes up. I mean, take a look at the Big Bang, for instance. They came up with space growing, uh, space increasing by size faster than the speed of light. So it gets around the speed of light phase in the first 1/2 a second of the Big Bang. Um, then galaxies aren't moving the way they should. The outside of the galaxies. So they come up with dark matter. Um, Gravity wasn't working there. And then they come up with say, oh wow, things are moving faster apart in the universe. So it's speeding up. It doesn't work. Gravity doesn't work. So they came up with dark force. That's not to mention the fact that gravity doesn't work at the quantum level at all. I don't wear a suit, but I keep telling people, I'll put one on, but I want it made out of that fabric, of space and time. But there is no fabric of space and time. Can't be done. Sure would like it though. Yeah, there's no fabric of space and time. It works good though. Einstein's theory of gravity, it works really well, and it does a great job of just about everywhere else. But it in fact fails on those few points and many more. Um, Additionally, there is a redshift created when light travels through the universe and gets affected by gravity. It does redshift. Um, Whatever, disbelieve if you want. But anyhow, I decided to look into gravity, and I thought that I was getting somewhere. Um, First, you got the atom. Okay, this is where gravity comes from, folks. This is the atom. Okay, and this is just my depiction of it. It most likely looks different. Um, well, let's first get into that great mystery of a wonder called what is it? One of the primal forces. Uh, okay, the two forces I was talking about are the strong force and the weak force. First off, the strong force, just gonna have to get rid of it. It's really force potential. Um, when the atom is formed, it is formed with massive amounts of pressure and heat. This causes the atom to form, and the protons um, in the atom, which are spinning, are placed in a way that the poles cause the field to be um, generated so that they stay inside. They're kind of like locked there because of the way the magnets are all arranged in a pattern. If you were to like take these three, take the protons out of one side of it, the atom would just like explode. Um, um, Basically, the weak force is so strong force is force potential. Okay, the force is there. It's being stopped by the magnetic force generated by the protons and the way they are situated. It doesn't let that force potential out until you rearrange the protons to let them out. Weak force is the when this is generated, if it's too heavy of an atom, it starts shedding. some of the neutrons and some of the protons are going to be going away. Really, that's just nature happening. It's um, when these are arranged a certain way, they all try to stay together because the force keeps them in. But when a little bit of neutron moves out, shifts this, then a proton will escape. So really, it's not a special force at all. It's just, you know, nature happening. Um, and that's my bit on strong and weak forces. Oh, and so the gravity is made up of both the pulling and the pushing effect of the atom and the spinning around of the positrons in the inside of the atom and on the electrons in the outside that are spinning around it. That will also create a field, and it'll modify the field that's created by the protons, and it basically operates as one field. Um, and that should do it for the gravity. The only way that I could think of to test that out would be to see if the particles exiting a neutron star or a black hole, those particles have been stripped down to where they're smaller than atoms. They're, those are streams of material that are made up uh, of quarks and stuff. And so therefore, they shouldn't, they shouldn't have the same gravitational effect as other matters with atoms that have the proper things happening with them. I'm not sure, but it could be tested by seeing what effects these streams have on other matter in the universe. So you might be able to test it. Anyhow, that's my theory on gravity. I think it's way too early, or I don't believe that we have enough equipment to properly test the gravitational effects of the spinning neutrons or positrons and the effects of the uh, electrons. But in the future, we're getting to that point where we might actually figure out the different ways and how much each particle in there affects gravity, and we could write an actual equation of it. But I don't know, I'm giving up, and I think I've gone pretty far. And we shall see what happens.